All right, welcome back. Now what we're going to do is shift our focus over to the ball class and get most of it complete. Logan?
All right, so shifting focus over to the ball class, let's begin with the one field that it contains.
Okay.
Now the ball is going to store a radius to represent the radius of the circle. So we'll put public float radius. All right, now the next thing we need to look at in ball is a property that will allow us to get the ball described as a rectangle. Basically, when we get into collisions are going to be done on a rectangle-to-rectangle basis. And at the moment, the only things we have to describe the ball are its position, which came from actor, and its radius, which is great for describing a circle, but not so great for describing a rectangle.
Right.
So we'll take all these things that we have and build a rectangle out of them. So we'll make a public rectangle property, which we'll call bounds. And this property is going to have only a get accessor, so it'll be
read only.
Read only. All right. So in the get accessor, what I'll do is I'll return a new rectangle, and then we'll use the rectangle's constructor to specify the rectangle. So for x and y, what we'll do is we'll cast over to int the position. So this is this ball's position minus radius, because we want this to act still centered. We want to get bounds that are centered around the very center of this ball. So
right.
x and y actually need to be up and to the left some. So in order to get that, we'll subtract radius.
And let's go and put those in parentheses as well so that we're casting the result of that.
Right, since both position and radius are a float, so we'll cast the result of that subtraction over to int.
Okay.
And tab over and do the same for y. So I'll cast int the result of this dot position, and I believe I'm missing the x and y components there.
You are.
So we'll jump back in time at half a second. We'll drop x down and y as well. And again, it'll be y, or this time it'll be y minus a radius. And all right, that takes care of x and y for the rectangle. Now we need to add width and height. And width is going to be the radius times 2. And the height is going to be the radius times 2 as well.
So basically what Logan did was got the upper left-hand corner and the bottom right-hand corner.
Exactly. So that has the rectangle property, or the bounds property, in place.
Okay.
And what I might even do is add a region around these just so we can collapse them and clean up the screen a little bit. We'll make a region called properties. And we'll make sure we define that as a region. And I think that had a P in it. There we go. And end the region. Then we can collapse the region and move on.
All right, so let's go ahead and get a public constructor in a place that's going to take in a float radius and set it.
All right, so we'll make a public constructor for ball. Now, since the radius is necessary for defining this and using it, we'll make sure that the constructor simply requires a radius be given. So the parameter here will be a float called radius. And we'll turn right around and implement it, which is just one line. The call to this.radius will set that to the given parameter radius. All right.
Okay, let's go ahead and get update in real quick.
All right, so let's do, this will be public. Of course, we're overriding the method from actor. Well, since we do override, let's pick update out of the list. And I'm going to wipe out a call to base.update since I know that the base doesn't do anything. And I might just drop down comments here because we need to skeleton the methods before we drop in here. So we'll just say check collisions. And we'll come back to that once we get some of the other methods in place.
Okay. Let's go and do our override for draw real quick so we can get this guy drawn to the screen.
So we'll drop draw into place. Again, I'll wipe out the call to the base. And let's make a call to sprite batch. So we were fed in a sprite batch. Let's use that sprite batch to draw out the ball texture. So we can look at game 1 and look at its ball texture field. And we want to draw that at the position of the ball. So we'll put this dot position. We aren't using any kind of a source rectangle. As a matter of fact, let me jump down a few in the overloads we're using. We're actually using the 6th overload. So next is the color, which we can get in this dot color. Rotation will set to 0f. The origin For the origin, I'm going to make a new vector in line here. So we'll do new vector 2, because the origin centered was just going to be the radius. So we'll use this dot radius for both components of the vector 2. And that will make our origin. And if I drop down back to the 6, okay, the next thing we're looking for is scale, which I'll set to a value of 1. The sprite effects will be set to none, and the layer depth will be set to 0.
All right, and it's really that simple. Now I guess we can go ahead and get our basic wall collision out of the way. We've done this, it feels like 100 times now. We'll go ahead and throw that in real fast.
All right, we'll get the outer wall collision put in, and that is going to be the private void check wall collision method. Wall collision, and then we'll just look at all 4 walls and see if we have happened to collide with them. Begin probably with the left wall. So if this dot position dot x is less than this dot radius, so that way the edge of the ball will collide, not the center. So if we have indeed gone less than the radius, then we've collided with the left side of the wall. So the first thing to do is to reset our position to the left side of the wall. So this position x set to this dot radius. And then we'll reverse the velocity in x. So this dot velocity times equals -1. All right. So I guess we could copy that block and change it slightly for the collision with the right wall. That would be if x was greater than the game 1's screen width minus the radius. And if that was the case, that's what we need to set the position to. And again, reverse velocity. And looks like I didn't put the x component in, because it's only x that we want reversed. Otherwise, we get a really weird bounce where if the ball is going up, hit the right wall, it would start going down again.
Right.
And I'm also going to change that to an else if, because if you're colliding with the left wall, then it's not possible to be colliding with the right wall as well.
Right.
But now that we have both of those, I could copy the entire thing, paste it in below, and we could do the same checks for y. So if y has hit the top of the screen, y is snapped to the top of the screen, and direction in y is reversed. Or if y has hit the bottom of the screen. So let's change this to screen height. And the same is where we'll snap it. And all of these are set for position and velocity in y. And that should be everything for check wall collision.
Okay, so now what we can do is go ahead and jump back up to update and make a call to this particular collision check.
So that means we make a call to check wall collision.
All right,
Okay.
With that, we're ready to test it out. I was thinking
I was going to skeleton in the last method, because once we do that, we're
Okay.
done. We're done with everything we're going to do to this class in this video. I was going to drop that in place because that way we can put the call into update.
Obviously, we know that we're going to be colliding with blocks at some point. So
we'll make a check collision with, what did I call that?
it's checkbox collision.
Oh, okay. For a second, I was like trying to describe it out in my head and it wasn't working. Check box collision. And we'll leave this method as a skeleton for now, because this will come into play when we have a collision system that can handle box shapes.
Might as well go ahead and jump back up to update real quick and put a call into that. That makes update
for
complete.
Sure. So we'll check wall collision and check box collision.
Okay.
And now that is everything that we're going to do in Ball for this video.
So now we can jump back over to the game class and hop down to our create demo actors method. And let's get one of these balls created and send it off in a direction.
All right, I'm going to make a temporary or a local variable here to store a ball, and then we'll turn around and initialize that to a new ball, new instance of ball. Of course, it's going to take in a radius, which we have defined as ball radius. Then we'll take that ball and set a velocity, maybe, I don't know, 3 by 2. So now if we run, we have, oh, wait a second, we have a few errors before we get past here. Velocity, oh, whoops. Wow, that was weird. I combined, what happened was I saw V, so I combined velocity and vector in my head. So velocity equals new vector. And screen height, did I misspell screen height somewhere?
Yep.
I did. And
one more
time here. There we go. All right. Very simple errors, everything out of the way. Now we have one ball spawned and bouncing around the screen. So
cool.
There was right, bottom, left, and top, so all the sides are working.
Okay, and I believe that's everything we set out to accomplish in this video, right?
Mm-hmm.
So with that, that's going to wrap up this video.